I'm Francesc Campoy, and this is Just for Funk. Welcome to episode number 15 of Just for Funk. Today we're going to go back to one of our favorite things here at Just for Funk, which is to do a code review. And I'm going to be doing a code review of something really simple that one of my coworkers, Sandeep Dinesh, wrote using Go in order to basically read from standard input and then send to Google Cloud Platform logging. But also you could imagine that it's logging to anywhere else, and also send it to the output, standard output. It may seem like it's a simple program, but actually there's a lot of things that could go wrong with it. We're going to be talking about error handling. What's the best way of doing error handling in such a small program? We're going to be talking about how do you handle things like Control-C? Like if you get a signal, how do you handle it? Which means that we're going to be using channels, and we're going to be using concurrency, and we're going to be using a bunch of different things all together to make sure that our program is as robust as possible. Sounds fun? Let's do that. I'm going to start with a directory that has only the code that Sandeep wrote. And before we start modifying anything, let's see what the program does for now. So the first thing it does is, well, it creates background context. If you don't know what a context is, go check the episode on it. I think it's episode 9 or 10, or maybe both. So go check it out. There will be a link somewhere up there. So after that, we define two flags. The project name. So in Google Cloud Platform, there's always a project ID. And we want to know where those logs should be sent to. Also, what is the log name, which is the name of the log to write to default. Okay, so when you're actually logging something, you need to give a name to that log so we can then find it in our logging console. We'll see that later on. Do not worry too much about it. But basically, there's two flags: the project and the log name. We parse those flags. We then get the values of the project ID and the log name. If the project ID is empty, we fail. So we print and fail. Otherwise, we check if what we're receiving is a pipe. If we're not able to check, then we're going to panic. Otherwise, we'll say, hey, there's nothing piped in, so there is nothing to log. Oh, I understand, because either it's a pipe or a standard input, like from a command. We don't want to be doing that. We don't want to be logging apparently. So that's why. Makes sense. Then we're going to create a logging client with project ID, as we saw before. If that fails, we log fatal. We're going to create a client logger, so a logger itself. And here's where we use the log name. And then we're going to create a standard scanner from the standard input, which is going to allow us to read line by line. And for every line, we're going to get the text of that line, print it to standard output, and then send it to the logger by using this logger.log with a logging entry. Then we check, as we always should, if the scanner failed. Like if we failed by while reading anything, then we just log fatal. Otherwise, we close the client, and closing the client will also flush. And finally, we finish by saying finish logging. So 85 lines of code, not very complicated, but there's actually a lot of subtle ways this program could fail to do what it's supposed to. So let's see them one by one. I would like to start with something quite simple, which is what I want this program to do is to everything that comes from standard input goes to standard output, and whatever fails goes to standard error. That's why we have two outputs, right? Standard output is the actual output of the command. Standard error if something goes wrong. Now, in this, we're kind of doing that, but not really. Let's see the errors, the possible errors we can have. So, when the project ID is empty, we do fump.printf. So this will print to standard output, and then return. So this will fail with exit code 0, which is like not failing. So let's see what I mean by that. So if I do go build, and I run this, let me do go build log pipe. So it generates a binary name log pipe, and I execute it by itself. You see this green arrow. That means that the error code was 0. I want it to be red. I want it to be something like if you do something that doesn't exist, you see this red arrow. That means that the error code, the return code was not 0. Also, if I run this command and I'm piping it to some output, let's call it auxiliary. When I run it, I would like to see the whole error directly here. And here we're seeing that one of the lines, the required flag -p project was not specified, goes into standard error. That's why we still see it here. But this one, please specify a project ID, goes to standard output. So what I'm going to do is I'm going to say, instead of printf, do standard fprintf and send it to standard error. OK, so now if we do go build again, and I run log pipe, and I send it to aux, I still see the whole thing. But still, this is saying that the command worked correctly, which is not what I want to do. So instead, I'm going to do os exit of 2. And then I do not need return, because os exit will actually stop this program and set the return code to 2. So let's go build again. And now I will run it. OK, perfect. Now we get the whole output here. And also, we see that this failed, that there's error. The return code is not 0. Choosing between 1 and 2, I really don't care. As long as it's not 0, you're good. OK, what about this case here? Well, in this case, it will panic. So it will panic and print something to standard error. But I do not see why we should do this as a panic. Instead, let's simply do fprintf could not stat standard input, and this is the error. OK, and this goes to standard error, and then os exit of 2. OK. Similarly here, we're going to do exactly the same. If this fails, we're going to do exactly the same again. Failed to create client. And if this fails, we're going to do exactly the same again. Let me copy paste again. So you get the thing. It's not very complicated, but the good thing is that then the whole behavior is going to be more uniform. No matter how the program fails, it will fail pretty much always in the same way, showing you the same things. And then here, fprintf ostdr finish logging. Now, I would say that printing this is not very Unix style, because in Unix, what you say is that no output is good output, right? So if I print anything, some people would interpret that something failed. So it is better, if everything works, not to print anything into standard error. So I'm just going to drop that line. Cool. So now that we have all of this, I realized that, well, why don't we simply say, instead of having this, I'm going to call this error f. And I think that I changed that pretty much everywhere. OK. Multi-cursors are amazing. OK, func rf. So we're going to have our argument, our format, which is a string, our argument, which is a bunch of interfaces. And what this is going to do is going to print format and args, and then os exit of 2. OK. So now we do pretty much everything. We handle every error doing exactly the same, which, you know, I like. OK, so go build -o log pipe, run log pipe, and it fails in some way. If I do aux, it fails, but still shows everything correctly. If I did this, no, I never remember how to redirect to 2. Is it maybe like this? Oh, no, I think it's like this. Okay, cool. So now we didn't get anything to standard output, but we redirected standard error with that little ampersand to aux, and in aux we have that error message. Cool. So everything works as we expected. Nice. Okay, so the next step is to make sure that we do the error handling in a correct order, or at least as little as possible, but as much as needed. Okay, so we're going to start by going line by line and seeing where the errors are handled or not, and whether they should be handled or not, or in that order, or something else. Cool. So flag.parse returns a slice of strings, which is the arguments, and also an error. This is a package that Sandeep wanted to use, which I think is pretty cute. It allows you to have short and long form, which is, if you use command line, you might appreciate that. And also requires you to have required, so you can say this value is required or not, and then default, which is the default value for the flag, it has not been defined. So, it's a little bit more featureful than the standard library. I would still use the standard library, to be honest, but let's keep it like that. Why not? This returns an error, and we're ignoring it. So what I'm going to do is, since this already prints, whenever there's an argument that fails, already prints something, we could do os exit of 1 in here directly. Because since this actually checks for required, so if we do go run of logpipe.go, this should fail directly, exit status 1. If I do, okay, so this might be the way to do it. Cool, so now since this fails because the project was not specified, we actually don't need to check for this. So there's one less prompt to check. Good. Then we're checking if we can stat or not. Then we're checking if the pipe is named or not, which is good. We create a client. We create a scanner. I'm going to change the name of this because I always call it S, and I feel like it's easier. Then we get in the text. We're printing it. We're logging it. OK, so now here there's another problem. We're checking for the error in the scanner, and we're checking for the error in the client.close. But if there's an error in the scanner, which means we failed somehow to read some line, then what we do is we panic. Well, we panic. We exit the program without closing, right? Like we didn't close the client here. So what I'm going to do is I'm actually going to move it to the other way. So I'm going to say first we close the client no matter what. If closing the client fails, I'm OK stopping the execution and not printing anything else. Otherwise, I will actually check for did we read all the lines, and if something fell, then we error. Why do I do this? Because otherwise, if we exit without closing, we will not flush the client, which means that some of the lines that we thought we had logged will not be actually logged. So that's basically the whole problem. Let's try to run it actually. So if I build it again, and I do log pipe gcloud config list. Okay, so I'm using already this project. So I'm going to do log pipe -p of this project. Nothing is piped in, so there is nothing to log. Okay, so let's do cat and pipe to that. So now anything that I write here will be sent to the program. So if I do hello, and then I exit, cool. So I did Control D to finish the standard input line. So if this actually worked, we should be able to go to Google Cloud Console in my project, then go here to logging, logs, and let's see, hello just for func friends. Let's see. Let's flush. And there you go, it appears. Cool, so we see that this program is actually working and is indeed logging to the output here and also logging to the console. Cool. Are we done? No, we're not. There's more to do here. Let's see what else we could do. So next I'm going to do a couple of changes that make the program a little bit smaller. One of them is going to be project ID. We get a pointer to that value here, and then we dereference the pointer to use it here. So what I'm going to propose is to simply use the project ID directly there, and then we can drop this. Same for log name. We do exactly the same. There's no point in doing that. OK, so that makes it a little bit simpler. Also, I'm a big fan of declaring variables right before you use them. This is not C where you need to pre-declare things from time to time. So I prefer to use these right before you use the context, which is right here. Cool. And we could say, are we using context anywhere else? We're not. So we could even say that this could be used here directly. But, you know, that's not a big difference. But at least the context is declared right before we use it. I'm going to move this up here a little bit. And now the program looks a little bit better for me. Just a little bit simpler, you know. We're still around 80 lines of code, even though I changed a bunch of things. Great. So next, what we're going to do is we're going to try to simplify the part where we're reading from standard input and sending it to standard output and to log. So this actually has it is pretty common to do this thing where we have one stream of data coming from one way of a reader, and we want to obtain a new reader. Like we want to keep on reading from there, but also we want to send all the things that we receive from the reader to a writer. And if you see, rather than seeing it on like left to right, you see it bottom to like bottom up, you could imagine something that goes like you have the reader, you're reading, you send it to a writer, and also you send it to your own code. And if you see the shape, it's kind of like a T. So that's why this is called a T reader. The same way this is called a T-shirt, right? So the whole idea is that we're going to have that shape happens pretty often. Probably in your code, you have some places where you do something like this. The standard library offers a type specifically for this. So what we're going to do is we're going to simply create a standard. So we're going to create a new reader from that standard input. So we're going to have, rather than the standard input here, we're going to have a reader, which is Iot Reader. I'm pretty sure it's called T Reader. There you go. And that receives two parameters, a reader and a writer. We're going to be reading from standard input and writing to standard output. Now that's a reader, so we can use it directly here too. And now this part of reading from standard input and sending it to standard output is not needed because we're already doing it through the T reader. So we can drop this part and then move this text here. There you go. This does exactly the same thing as before, but it is much simpler. And if you know what a T reader is, and now you do, this code is also very simple to understand. OK, so the next step, now that our program works and looks pretty nice, is to make sure that it handles all of the errors and all of the use cases. And one of the errors that could happen to processes is that they receive a signal. Now, signals are signals that are sent across processes on most OSs, and they allow you to do things like request a process to stop. In this case, for instance, we can say an interrupt signal. We can send that with Control-C directly, or we could also use the kill command on Linux and Mac OS. And that will happen is that our program will handle it gracefully or not, and something will happen. So let's see if this is working correctly in our program for now. I'm going to add back our func to standard error saying that finished, OK. And I want to make sure that this is actually printed, because if this is printed, then it means that we indeed close the client, and then we check that all the input was correctly handled, and then we finally exit, right? So this is what I want to make sure that that happens. So if I compile my program and I run log pipe -p foo cat that. And then here not cat, PS. I have my cat program, my log pipe here. So I'm going to do kill-2 to log pipe. Sorry, not to log pipe, to the process ID. Okay, so now we should be able to see that the program finished without saying absolutely anything. Not awesome, right? Like that is not what we want. Let's try it again. So if I do hello, it prints hello. Permission denied. Sure, that's okay. We'll see that in a minute. If I do PS kill-2 to this and go back here, nothing, silence. Not good. We want to make sure that we actually log everything that we call close. So how do we handle that? Well, what we need to do is we need to use the os/signal package in order to handle signals. So we can do it up here at the beginning and do signal.notify. And that will add our OS signal package up there. Signal.notify gets 2 arguments. Well, 1 argument and then a variadic argument of signals. And the first one is going to be signals, which is going to be a channel of signal. We're going to pass signals, and then we want to pass all the signals that we want to handle. And I'm going to say that we only want to handle interrupt, which is the Control-C, and also the -2 that we sent. Actually, if you look at the documentation, we should be able to see that sigint is defined to be 2. So it's a signal with value 2. Cool. So that signal, this program now will not do anything new, but a new value, a new signal will be sent to the signals channel whenever a signal is received. So we could do something like go func signals. Let's receive our signal. So let's receive our signal, and then we're going to do rf received signal, and that's the signal we received. And of course, we actually call that because then you go routine. Okay, so with this now, what we're doing is we're actually doing something with that signal. What we're doing is not necessarily correct because we'll actually not get to the end of the program and run our log here saying everything finished okay. But let's see what it does now. So if I do my go build, and then I run cat log pipe, and now I go here. So PS, let's kill that, kill-2 to that. And now receive signal interrupt, and then now we saw why this finished. Now the problem is that, as I was saying, we did not print anything, right? So now what we want to do is we want to be able to have either we receive a new line from the scanner and we send it to the logger, or we receive a signal and then we exit. So how can we do this? Well, the way to do this correctly is to use Go routines. So what I'm going to do is I'm not going, not to use Go routines, to use Go routines, but also to use channels. So here, what I'm going to do is I'm going to create, so I'm going to move this a little bit lower. I'm going to move this here. So rather than scanning and logging directly, what I'm going to do is I'm going to have lines, which is a channel of strings, and I'm going to create a new Go routine that's going to simply go go func. I'm doing something wrong because this is not formatting it correctly. What is the problem? Oh, there you go. It's pretty slow. Oh, this does not compile. Okay, cool. So we're going to move this inside and remember to close, to flush first. Okay, lines. So whenever we receive this, we're not going to log yet. We're going to send s.text to lines. And then we're going to have a for loop with a select statement. And if we receive something from lines, we're going to log. So this now can be done down here. Sorry, not text, but line. But also, if we receive something from signals, we're going to printf received signal, terminating program after received signal to the standard error. We're gonna also do something really similar to this rather than failing. So if we get an error, we'll print the error saying we were not able to read anymore, so we're gonna be finishing. But this is, we're gonna finish this code routine. How do we know that we finished this code routine? Okay, client.close unreachable code, yay, because we want break here. And actually we want break main loop. So break loop. Okay, this might be a little bit complicated, but let me explain. So we've broken our program into two different Go routines. We actually, two different Go routines, technically three or more, but the two that we've written is one Go routine that is going to be reading from standard input and sending to standard output through the T reader. And for every line we read, we also send it to lines, lines which is a channel we're going to be reading it from. If something fails, we will print an error, but continue. Next, if we receive a signal, we're going to break the loop. So if we receive a signal and we initialize that up here, we will exit the loop. Let me initialize this with the, there you go. I like that better. With the logger, everything logger related is initialized at the beginning. So we initialize our signals. If we receive this signal, we will print the signal and break the loop, which means that we will go and close the client, flush all the buffers, and then print finished OK. If we are done reading from lines, we should also exit. So the way to communicate that is to say defer close of lines, and if not OK, then break loop. That means that there's no more lines coming in. It might be because there's no more lines, or simply because something failed. We do not know. We do not really care. Instead, what we're going to do is whenever lines is closed, we know that we're supposed to finish the program. Cool. Let's try to run it. So go build-o log pipe. We run this on one side. We do PS. We send a kill-2 to this. And terminate program after receiving signal interrupt. Oh, we should have Control N up there, Control N up here, and Control N up here. I feel like we have Control N everywhere. Maybe we should just simply add Control N here. That'd be probably simpler. So now I can drop it. I cannot drop it from there. I cannot drop it from there, but all the error F, I can drop it from here. I can drop it from here. I can drop it from here. Error F. Cool. And our program still will finish, but now finished. Okay. Just to make sure that this actually works better now, let's do it again. So PS kill-2 to that. Finished okay and finished okay. So now we know that this actually finishes okay. We can get rid of this. Now I want to make sure that this actually works. So what it can do is go build -race-o log pipe. And this will generate a binary that has data race detector enabled, which means that our program will be way slower, but it's fine because basically it will allow us to make sure that what we're doing is probably correct. Doesn't mean that it is 100% correct, but it might detect some errors if there are. So let's try to run that now. So we do that. Hello, prints hello, and it fails, and we'll figure that one out in a minute. But okay, so we have PS kill-2 to this. We come back here. Our program is done. Everything worked correctly, and no data race that was detected. So this looks pretty good. Now, to finish, we're going to try to understand what's going on with this permission denied. So the permission denied is totally normal in this case because what I'm doing is I'm running and I'm trying to log stuff to a project named foo, right? Like it says foo. And this is not possible because I do not own the project named foo. Probably there's one and probably someone owns it, but someone probably that started using the platform quite early on, I imagine. Probably a Googler. So I'm not able to do this, but I only discover it whenever I try to log something and that fails. And I could say there's a way to, whenever an error occurs, I will receive, I can send a mess, I can pass a callback. So that function would be called with the error, and then I can panic or errorf or whatever I want to do. But the problem is that I do not want to do that because I want to log as much as possible. So if logging one of the lines fails, it's okay. Just continue. Keep going with your life. I don't want to just stop the whole logging because one line. But I want to make sure that whenever I start log pipe, if this is not correct, it should do something about it, right? So when we create the client, we can check that the client has all the needed authorizations, all the rights, that we own the project and that we can actually log. And to do this, we're going to do ping. We're going to pass the context. Let's say that we want to do context with timeout. So after 1 second, if we're not able to ping after 1 second, then something is wrong, so we're just going to fail. That will return an error. And if that error is not nil, fail to ping logging service, and this is the error. And we'll exit that way. What is the problem? Ping received too many arguments. Sorry. Context and cancel. Defer, cancel. Pass the context. Okay. So context with timeout returns context with a timeout, and also a ping. Sorry, a function that we need to call whenever we're done with that context. We could do defer, cancel. That is a way of doing it. The other way of doing it that is probably better is to actually call cancel here and cancel here. But I do not care enough about this tiny context that if we leave it there running for long, it's not really an issue because it's not something that we're going to be doing repetitively. We just do it once at the beginning of the program. So this is fine, in my opinion. Okay, so go build again. I'm bringing with data res detection. why not? Just to make sure everything is okay. We're doing cat log pipe foo, and the color does not have permission, and the program exits. Cool. So now we're able to actually see that this program is not correct. But if we do just for func test, the program does not complain just yet. I can do hello just for func in a console. Thread. Save. We should be able to see it somewhere. We'll send that. Oh, we saw the ping. It doesn't complain. That is the ping we're sending. We go to our to make sure that we can log. So you will see this at the beginning. Is the only way this can be done. Which it's sad, but that's how it is. And then we see hello just for func in a thread save way. Cool. So then I can do Control-C. And we receive the interrupt. So everything exit and everything just worked correctly. Great. So with this, we're done with the episode. Let's see all the things that we modified. First, we made sure that all the errors were handled the same way, uniformly, and all being sent to standard error, not standard output. And then making sure that we always exit with an error code that is not 0 if something failed, which allows us to understand better how the program did. Then we also change little things like make sure that all the variables are defined right before they're used and stuff like that. It makes your code a little bit simpler to follow. We added a T reader that allowed us to remove one step by saying everything that comes from standard input should go to standard output. And also we would like to read from it for something else, which is the logging side of things. And then finally, we made sure that the signals were correctly handled. And to do so, we actually added concurrency with channels and select statements. Great. So I hope you enjoyed this episode. From now on, these episodes are going to be coming on Mondays every 2 weeks. So make sure that you subscribe so you don't miss any of the next episodes. Let me know if you have any ideas. You can send your ideas either on Twitter @Francesc or directly to a form that I created just for you. It's called forum.justforfunc.com. So you can go there and send me all of your ideas, questions, or any propositions you might have. As always, thanks for watching. If you're going to be at GopherCon in Denver on Wednesday, I will be there too, so come say hi. And if not, see you all in 2 weeks.